Alright, to make this 4-pin trailer lamp tester, I've got a sort of generic, it's certainly brandless, plastic project box that I bought from Amazon. I'll show a link or something. Decent quality box. It's set up to have a gasket, which came with it. It's the kind of thing that's like a elastomeric rope that you just push in there and then into the lid, and then there's this raised area that engages that and seals it up. It has captive screws, so the screws go into metal fittings, not into plastic. That's good. The main things I have to fit into it is I'm only going to have a 6-volt battery. I have this Drock, also bought from Amazon. That's their model number. It's a DC to DC converter. Intended for powering automotive things that require 12 volts when you only have something less than that. Anywhere between 5 volts and 11 volts in, and then it puts out 12 volts up to 1 amp maximum. So there's that. That'll get me up to the 12 volts necessary to test the lights properly. Got the battery holder. I'll put in 4 AA lithiums for that. I've got some mounting hardware for those things. I've got 4 push buttons. These are, again, sort of generic Chinese things. You can buy a bag of them for a small amount of money from Amazon. Again, I'll show a link. They're momentary buttons. I've got a yellow, a green, and 2 reds. And then from my own parts box, I've got an amber and a red LED and resistors and fittings to mount them in a panel. And those are the things that have to go in this box. Now, the first problem is that there's these protuberances on the inside which will get in the way. I need to remove those, and I'm debating whether I want to just put on labels to say what's what on here, or if I want to do a proper front panel. I may decide to go with the labels, because this is not something that needs to look very finished or professional. It just looks fairly neat. That's all it really needs to do. I did a quick and dirty sketch of the circuit. There will be a 6-volt battery, some sort of power switch, the DC to DC converter putting out 12 volts. I'll have a LED with a current limiting resistor to verify that there is 12 volts, or at least that it's outputting, and you can assume it's 12 volts because that's the type of device it is. Then 3 momentary push buttons for the marker lights, for the left stop and turn signal, for the right stop and turn signal, and those will get wired down to the plug of the kind that would come off the vehicle that's towing the trailer. And I intended to put another LED right on the battery after the power switch, so it's sort of a self-diagnostic. You turn the power switch on, you get the one LED, you know there's some battery power, and then you should get the other LED, assuming the DC to DC converter is working. And I'm going to make this, I was going to make this a slide switch, but it's easier to put in the round switches, so I'm just going to use another button. So you have to mash the green button and hold it, verify with the LEDs, and then mash one of the other buttons to test the lights on the trailer, and then release this button. That's the way I'm going to do it. Here's just a crude sketch showing a top view of the bottom half of the case, and how I'm going to put the DC-DC converter here and the battery holder here. And these are their approximate heights. on there, and the battery holder. And there should be adequate clearance for these buttons on the top in whatever pattern I put them, and then I can put the LEDs for verifying the power up above the converter. Alright, I put in a couple of 440, I think those are 3/4 inch long male-female spacers, and the battery holder using 440 by 1/4 inch, I believe, button head screws, and they're threaded into the back of the case. But because it's not very thick, and I wanted to make it stronger, especially in the case of the battery holder, I put epoxy around the back of the holder and let it kind of bubble up through the 2 unused holes. The screws were put in from this side. This is really intended for flathead recessed type screws into a chassis, not this exact type of installation. So those screws were selected because they will fit down inside there and won't hit the batteries in their holders. And I did put some red Loctite on the threads as well as on these. And once the glue cures a little bit, I'm going to grind those stubby screws off. So in the meantime, I can concentrate on the front panel. I cut a piece of paper the same size as the top of the box, marked out the low clearance and high clearance areas, and then figured out where I'm going to put the 2 LEDs, the left and right turn signal lights, or the buttons, not the lights, the buttons for the lights, the marker button, and the power button. So now I have to make the appropriate size holes. I've already center punched through so I can find where the hole centers are. So there are the push buttons and the LEDs installed. The LEDs are just in snap-in holders, little bezels. The LEDs snap into the bezels after the bezels are pushed through a 1/4 inch hole, and they work with thin plastic like this as well as sheet metal. And they also have these little round plastic bits that, if you don't find these are holding firmly enough, you can push those over and they kind of ratchet on and help hold them even more firmly. But I don't think I need those here. So I'm going to be using the amber as the 6-volt light or indicator, and the red is the 12-volt. I have the component spaced so that I can put 1/2 inch Brother P-Touch series labeling on the panel here. Well, I use my Dremel grinder to cut off the, or cut-off wheel on the Dremel, that is, to cut off the protruding threaded section of those screws and spacers. And because of some reflections, I got closer to the plastic than I wanted to. My usual thing is to cut them off just a little bit protruding and then carefully grind away the remaining little bit. And here with the black screws I couldn't really see what I was doing. With these I did a better job. This one was pretty close to ideal, but anyway, it's on the side that doesn't usually show. So everything's pretty well dried here now, and this DC to DC converter, I drilled a couple of extra holes in it so that I could use reasonable size hardware. These really big openings were ridiculous for this situation. So I can put it in like that. Like that. Little 440 button head screws there. I'm holding off drilling the hole for the cable until I receive it to make sure I drill an appropriate size. I used a little bit of super glue around the LEDs to make sure they didn't wiggle. And I'm designing the labels in my Brother P-Touch editor. So I printed this on 1/2 inch wide Brother TZ series tape, white on black background. And let's see, it looks like the spacing is about right. Alright, there's the labeled front panel, 4-pin trailer light tester, 6 volts and 12 volt indicator lights, left and right, power and markers. I've worked out which way I'm going to flip the cover when I open it, and it'll be this way. That makes for the neatest wiring. And I have to have a little terminal board there for the incoming 4 wires from the cable, which I plan to bring through a hole right about here. I'll know the size of the hole once I get the cable in, and it'll use up 4 of these 5 terminals, and the other one will be a common point for the positive side of the 12 volt power supply, whereas the trailer circuit ground will be the common point for the minus side of the 12 volt output. I don't really need a common point for the 6 volt circuit because it's so simple. Mostly I can use terminals on the push button switches for that. For the LEDs, I decided to just go this route. I bent the leads on the LEDs, soldered to the current limiting resistors, super glued them to the inside of the cover, bent the leads up so I can attach wiring to those, and I'm just going to use their own mechanical strength for this. I toyed with making up a little circuit board or something and decided it wasn't worth the effort. Alright, I've got the wiring done. I've got this added terminal which is going to screw into the back just about here. The cable's going to come in below that, at least according to my plan, and then immediately fan up and go to the everything except the center connector there through these outer lugs. The interior wiring is going to the other holes down here on the base, except for the one place here. And it's all just point to point, daisy chaining around. I do have a common on the input side of the converter, so the 6 volt side, where the minus side of the battery and the minus side of the converter input, and the common lead to the 6 volt LED, not wire nutted but twisted together, soldered, and then heat shrinked over it. Everything else is point to point. No splices other than that. Alright, just a little bench testing. I've got the lid partially screwed on, but the connector for the trailer wiring cable just sticking out the back of the box. Got my multimeter clipped onto the common terminal, and I'm going to do an initial voltage check to make sure that I'm still getting the 12 volts, and then I'm going to check the 3 circuits. Alright, if I push the power button I should get both LEDs. Got both LEDs, and I am getting 12 volts at the on the secondary circuit of the converter, just as expected. Looks like there's a little capacitance inside the converter, which I would expect. Has to have some way of smoothing the chopped waveform. Now I'm clipped onto the marker light circuit, and I've got 0 volts there at the moment. When I push the power button and then the marker light, the output goes to 12 volts. I release the marker light button, goes back to 0. I've clipped onto the left circuit. Okay, push the power button, push the left button. 12 volts on that circuit. Move the test clip over to the right circuit. Power button and right button. Everything in here is working. The only thing I'm not really certain of is how long the batteries will last powering the trailer lights and the load presented by the DC converter, which shouldn't be very much. I'm pretty certain that it'll work at least for short periods of time with the LED lights on the trailer. I don't know about powering incandescents. I may try hooking up a couple of bulbs and see how it behaves with that kind of load, but at the moment at least the wiring in here is good. Alright, the 20-foot 4-pin extension cord that I ordered has shown up. I've kept this plug and cut off the one on the other end, and I found that by folding the cable once over on itself, it just fits through the smaller grommets that I have in my junk box. So I'll use those. I could just drill the hole in the plastic, but I'm going to do this. And then probably I'll put a tie wrap around it real tight so that it won't pull back through that, and that should give me enough strain relief. Alright, that grommet is in there, snapped in perfectly. And all I have to do is stick the wire through, solder it up, and remount this terminal strip, and this should be done assembly wise. Alright, the wires from the trailer cable are all soldered up to the terminal block. White, brown, yellow, green, and they mostly tuck out of the way. There is enough room to get at the batteries for replacement, or the cells in the battery for replacement. And I've slightly bundled these wires coming around here just to make it less of a rat's nest around here. There's not any reasonable way to bundle these wires, so I'll just let those go. Alright, the cable from the tester plugs into the cable on the trailer. And if I push the power and markers button, that's working pretty good. And the long cable allows me to walk all the way around the trailer, and so far so good. And let's check the left brake turn signal. No problem. All the wiring on here is working just fine. Of course, the marker lights come on with the headlights, so you want these lights to be on when the marker lights are on. So we not only get the side light and the license plate illuminating light, but we get the marker light. And now if we have that all turned on and I hit the left brake light, that seems to be working properly.